Welcome everyone. So this lecture is about Chandrasekhar's limit. Subramaniam Chandrasekhar in 1920s or 30s was working on white dwarf stars. What are white dwarf stars? White dwarf stars are basically dead stars. Our sun will one day explode and become a red giant and leave a white dwarf. And Chandrasekhar was working on white dwarfs. White dwarfs have a hydrogen shell, helium shell, and inside carbon and oxygen core. And the gravity is working inwards. And there's electrons. Now, as we all know, electrons would repulse other electrons. So this electron repulsive force balances out gravity. And so the gravity is working like this. Gravity is working inwards, acting inwards, and the electron repulsive force, also known as electron degenerate pressure, would hold the gravity and balances the two forces and keep the white dwarf at bay. But what Chandrasekhar found was, with his equations, that when the star is more than 1.5 times the mass of the sun, this electron degenerate pressure is not enough to stop gravity. So you have gravity acting inwards, and you have the electron degenerate pressure, repulsive force between electrons, holding back the gravity. But when the mass of the star is 1.5 times the mass of our sun, then there's something called core collapse would happen. So the core would collapse because this electron degenerate pressure is not enough to hold back gravity. So the core would collapse, and it just keep going, and then we found out that it would explode and it would become one big neutron, and there would be a neutron star. But when the mass of the star is more than 2 or 3 times our sun, then even that is not enough. The whole thing would collapse all the way to zero volume. And now we are going to have singularity, zero volume, or undefined volume, whatever the way you want to look at it. So now suddenly we are finding these equations by Schwarzschild. We said that these equation by Schwarzschild had no meaning. I mean, when r goes to 0, this becomes infinity, and the singularity. Now suddenly Chandrasekhar's findings show that it is possible during a star collapse, when a star collapses, that black holes can form. So that was a major breakthrough, because before this, even Einstein, everybody said, well, these are just equations, they have nothing to do with reality. But now Chandrasekhar is showed us that when a star started to collapse, there's nothing to hold back gravity. It would just keep collapsing all the way down to zero volume. So the physical world, there is a possibility of singularity now. So due to this reason, it became clear that Schwarzschild equation is important again, because the Schwarzschild equation is not just a artifact, this mathematical formulation. In reality, it could happen. When a star collapses, you could get singularity. So there is a way that you can get singularity. When the mass of the star is more than 1.5 times the mass of sun, electron degenerate pressure cannot hold gravity. When the mass of the star is more than 2 or 3 times, nothing could stop gravity. would go all the way down to zero volume. In the next lecture, we would eventually start Raychaudhuri equation and what Raychaudhuri did, and how it is important to singularity. Thanks a lot for listening.